All right, this is CS50, and this is week 1, our second week together. And you'll recall that last week, week 0, we focused on Scratch ultimately, this graphical programming language via which you can drag and drop puzzle pieces that interlock together, only if it makes logical sense to do so. And many of you had actually probably played with that in like middle school or even prior at some point. But for our purposes, the goals of Scratch were to give us sort of a mental model for some fundamental constructs that we're going to see again and again today in C, in a few weeks in Python, and even thereafter. And those include things like functions and return variables and arguments and variables and loops and conditionals and more. And so even if today feels like a bit of a fire hose, such as that pictured here, appreciate that a lot of today's ideas are exactly the same as last week's ideas. It's just that the syntax is going to change. It's going to look a little different. It's going to look a little scarier. It's going to be harder to sort of memorize, except with practice will come that muscle memory. But the ideas ultimately are going to be the same. And indeed, this is, if unfamiliar, MIT down the road has a tradition of hacks whereby students once a year do something fairly crazy. And at this point, they happen to connect an actual working drinking fountain to an actual fire hydrant. And the sign there, very pixelated, says, getting an education from MIT is like trying to drink from a fire hose. And that's indeed how computer science, how programming, how CS50 will sometimes feel. But realize that what's going to be ultimately most important is not where you feel you are day after day, but where 3 months from now you feel that you are relative to last week alone, so-called week 0. So let's look back at what week 0 looked like. It looked a little something like this, the simplest of programs via which we get that cat to say, hello world. Today, that same code is going to start to look a little like this, which was a glimpse we gave you last week. But this time, I've deliberately color-coded it to try to send the message that whereas in Scratch, we had this yellowish puzzle piece that sort of kicked things off, that didn't really do anything itself, but it got the program started, whereas the real work was done in purple here. Same is going to be true today, whereby I'm going to wave my hands for a little bit of time at this yellowish code on the screen. But what's really going to have the most effect is this same purple line here and the white text within. And we'll break down what all of these lines mean over the next couple of weeks, but sometimes we'll wave our hand at details if we feel it's a little unnecessary at this point in the story. And in fact, let me get rid of the color coding for now, and we'll see that this is the kind of code in a language called C we're going to start playing with and using today and for the next several weeks. And indeed, it's representative of what we're going to generally call source code. So source code is what programmers write. It's what you write. It's what you wrote, albeit by dragging and dropping puzzle pieces. This week onward, you're going to start using your keyboard all the more, and you're going to write source code. So this is code that we humans can understand with some training and with some practice. But of course, per last week, what language do computers ultimately understand? Only. So binary, zeros and ones. And so you and I, yes, can write code starting today in a form that looks a little something like this, which admittedly might look a little arcane and cryptic, but it's certainly better than a whole bunch of zeros and ones. But we're going to write in source code, but the machines that we write code for ultimately only understand these here zeros and ones, which may very well say hello world, but we're going to call this moving forward machine code. So machine code is what the computers understand, only the zeros and ones. Source code is what you and I understand and actually write. So it stands to reason that we're going to have to somehow translate one to the other, from source code to machine code. And I alluded to this ever so briefly last week, but we're going to use this same mental model whereby the source code we write might be the input to some problem. The output we want therefrom is going to be the machine code. So what we're going to equip you with today inside of this proverbial black box is a special piece of software that takes source code as input, produces machine code as output, and that type of program is called a compiler. And there's bunches of different compilers in the world. We're going to have you use one of the most popular ones, but it's simply a piece of software that someone else wrote that converts one language to another. Source code, for instance, in a language called C, to machine code, the zeros and ones that our Macs, PCs, phones, and other devices actually understand. So where are we going to do this, and how are we going to do this? So I promised last week that we'd introduce you to this here tool, which I used briefly at the very start of class to whip up that chatbot. We're going to use it, though, not for Python this week, but indeed for a different language, C. And indeed, this tool, Visual Studio Code, or VS Code for short, is super popular in industry. This is what real programmers, so to speak, are using all of the time nowadays. There's absolutely alternatives, if some of you have programmed before. You might have used or experienced different tools, but this is a very common tool that you'll see even after CS50. And in fact, it's something that ultimately you can install for free on your own Macs and PCs so that by the end of the course, you're completely independent of CS50 and any CS50 related tools. But what we have done for the very start of the class is essentially provided you with a cloud-based version of this tool. So all you need is a web browser on any Mac or PC or the like, so that everything's pre-installed for you, pre-configured for you, and you don't have to deal with the stupid technical support headaches at the start of the term because it should just work. But by the end of the term, once you're a little more comfortable with technology and with code in particular, you can absolutely offboard yourself from this tool, install it, download it on your own Mac and PC, and have pretty much the exact same environment completely under your control. So starting today, you're going to see an interface that looks quite like this quite often. And we used this same interface last week ever so briefly. Moving forward, here's where we're going to write code. At top right is where one or more code tabs are going to appear, similar to any tabbed environment that you might use. Here, for instance, is just a screenshot of the first file we'll create today called hello.c. The reason it's called hello.c is because it's in a language called C, as we soon shall see. No pun intended. Meanwhile, the code here happens to be color-coded, not quite in the same way as you saw before, because I manually made it look more like Scratch blocks. But among the features that VS Code and other programming environments provide is something called syntax highlighting, whereby you don't worry about or even think about these colors. But as you write out code in a recognized language, tools like VS Code will just color code different parts of your code for you just to make different features jump out. And we'll see what those features are over the course of today. But you'll also spend a good amount of time, as I briefly did last week, down here in the bottom right of your screen, the so-called terminal window, which is going to be where you run commands for compiling code and writing code. And in fact, as we'll see today, you're going to start using your mouse and clicking a little bit less. You're going to start using your keyboard and typing a bit more. And ultimately, even though if at first that might feel like a step backwards to sort of not use something that's so user-friendly, the reality is most every programmer tends to find themselves ultimately much more productive, much more powerful using the keyboard more often, more quickly than, say, a traditional mouse or trackpad would allow. Meanwhile, we'll see some somewhat familiar features here at left, like this is where you'll see the files and folders that will create over time. At far left here is going to be an activity bar, which is essentially a modern form of a menu via which you can open and close things and access other features. For my purposes, I'll generally hide this part here. I'll generally hide this part here so that when we're together, we're focusing almost entirely on code and commands. But I'm just typing some quick keyboard shortcuts to simplify my own user interface in that way. So with all that said, just some terminology. So this whole collective environment that I'm describing here is generally what's known as a graphical user interface. Why? Well, it's an interface for users that's graphical in nature, with icons and buttons and the like. Shorthand notation for this is GUI, G-U-I for short. But within this graphical user interface, as promised, is going to be that terminal window at bottom right, where I promised we would be typing most of our commands. And just to give you a bit more jargon in computing, that's generally known as a command line interface, or CLI for short, whereby you're typing commands into that interface instead. And the world of computing software is essentially divided into GUIs and CLIs, and sometimes a piece of software might have one of each as well. But without further ado, why don't we go ahead and focus entirely